Good morning, everybody. Happy Thursday, April 2nd, 2020. Let's talk about magnets. So, our I can statement of the day is I can explain how items can be electrically charged and cause motion. Here we go. So, magnets have these they're not really magical. They're created by their protons and electrons and all this stuff that you'll learn in high school. But basically, what you need to know is they have force fields around them. And these force fields show you the lines that which the magnetism, in a way, kind of follows. So, we know at the end of our magnets, we have the North and the South Pole. That's where the magnetism is the strongest. We can see that because if we look at this picture right here, that's where all these lines connect. In the middle of our magnet, we don't have any force field lines. So the magnetism is not going to be that strong there because it's not really connecting there. So what this goes into is how magnets interact with each other. They're buddies. How do they get along? How do they not get along? So if we have two of the same poles, they repel. Repel means to move away from each other. So if we have two south poles, they're going to move apart. If we have two north poles, they're going to move apart. So if we look right here in this picture, you can see that this is actually happening with the force fields because you can see that the lines that normally go off them, even though they usually go straight, like right here, they're not because they can't interact with two of the same poles. So they're going to move away from each other. They're going to diverge. Diverge means to go away. On the other hand, when we have two opposite poles, so a north and a south or a south and a north, they attract to one another. That means they come together. So as we can see right here in this picture, in the diagram, that these force field lines are coming together. They connect perfectly, creating one unison connection between magnets. It's beautiful. Next, magnets attract items that are made from iron. Iron is a strong, hard, magnetic, silvery gray metal. Well, that's a hard word. I'm going to work on that one. So, yeah, in order for it to be attracted to magnets, it has to be made from iron. How does that happen? We're going to learn about today. But first, let's talk about what are some things that we know are made from iron. So we have silverware, pots, pans, iron fences, keys, sometimes pens, the bottom of your actual iron that irons your clothes. Those are all some examples of things that we know are made from iron. Paper clips, the binder clip thingies. Yeah. So what is an electrical charge? Repeat after me, electrical charge. Great. One more time, electrical charge. Good. So when an item that is not a magnet starts to interact with a magnet, like another magnet would. Let's say that one more time. When an item that is not a magnet starts to interact with a magnet, like another magnet would. So what I mean is this is how our magnets interact. We know this. We know that some like poles repel and different poles attract. So what I'm saying is when an item that's not only just any item, an item that's made from iron, like one of these things, starts to interact with a magnet, like magnets interact with each other. Whoa! So this happens because the first magnet gets close to that object. What that means is the magnet gets close to the thing made of iron and it changes it and makes it start to interact with that magnet like another magnet would. Let's break it down. Breaking it down. Let's go. Step 1. We have a magnet and we have an object made from iron. In this example, we are using paper clips. Woo! Paper clips are made of iron. This should work. So we have the two items. That's the only step. Step 2. The magnet goes close to the iron made object. So we have our iron made object. The magnet's going to scooch a little closer. It's going to come a little closer. Then the magnet gives the iron object an electrical charge through its force field. So we've seen pictures of the force field right here. We know it has these lines coming off of them. So in this step, the lines are coming off and they're touching this iron made object, in this case being the paper clips. So what happens? The iron object now has an electrical charge that will interact with a magnet like another magnet, in this case, attracting to the magnet. So the magnet is sent its force field lines out. It touched the iron made object, it being the paper clips, Now the paper clips are going to react the way another magnet would. So they're going to attract or repel from the magnet. In this case, it attracted to the magnet. If you didn't know this, you can take a magnet and you can pick up paper clips without even touching them, which we'll go into more tomorrow. So that's pretty much it. You can make objects that are not magnets. Put on a little mask and pretend to be a magnet if you bring a magnet close enough to it and it's made of iron. You can do that. It's amazing. So what can happen when an item is electrically charged? An item will interact with the magnet like the way the other magnet would. So the item will attract or repel from the magnet. Basically, that sums up what I just went through. That's the only thing I'm going over today. I will see you tomorrow for Friday. Peace.